Welcome to Closing the Loop, a podcast presented by Lakeside Process Controls, where we connect you with experts, end users, and suppliers in the industrial automation industry. My name is 𝗧𝗜𝗠𝗘𝗏, Business Unit Supervisor at Lakeside, and your host of the show. Each episode will be featuring special guests from either Lakeside Process Controls, Emerson Automation Solutions, or other industry leaders. And we hope that through these conversations, we can quite literally close the loop between your current knowledge and the latest and greatest in industry. Our goal is to help educate you, provide you with ideas for improving both efficiency and safety throughout your facility. And with that, I'd like to introduce you to today's guest. He's joining us from Trillium Measurement and Control, and he's a resident expert on custody transfer applications and really all things Measurement Canada related, and his name is David Brown. Now, David Brown and I get into a really interesting conversation around, what is custody transfer? When does it apply? And most importantly, the specifics of Measurement Canada. What are the requirements? What do you need to know to make sure that you are in compliance? And then we talk about different technology used in these applications. Now, Dave has a range of experience. In fact, he was even at Emerson at one point. So he knows a lot about ultrasonic, which is what we talk about primarily in this episode. And then, of course, Dave has been around for a while, so he has a lot of fun stories to share about, in the field and different experiences. And so we'll turn it over to the episode. I really hope that you enjoy. I think you'll learn a lot. I absolutely did. And just a reminder, as always, don't forget to subscribe so that you never miss another episode. With that, we'll dive into it. Okay, well, welcome to the show, Dave. For those of the listeners who don't know you or haven't ever interfaced with you, you're a known entity in the Emerson world. Maybe could you introduce yourself and who you represent right now?
Yeah, for sure. So I'm with Trillium Measurement Control. So I guess what we're going to talk about today, but we're a Measurement Canada authorized service provider. One of the larger proving companies in Canada. So, and then also started branching out in some international work. So within Guyana and Wales and Nigeria.
Great combination. Eh?
Yeah, there you go.
You picked the locations, right? Yeah.
All the hot spots.
All the hot spots.
Yeah, they are hot.
So, it's a good vacation spot.
Yeah, there you go. Yeah, you sweat a lot.
So, like I said, you're a known entity. Maybe you could just go a little bit into your background, kind of where you got your start and, where you've kind of grown up in different organizations and how you found your way to Trillium.
Yeah, roundabout way, I guess. This year, as of December, it's 20 years for me in the industry as of this December.
I thought you were only 30.
I take my hat off and show my hairline, I guess. I give that away. But, no. So it started with originally with Emerson in 2005. So the Daniel division. Then Daniel merged into the Emerson Flow group, and I became part of the ultrasonic group, or the product group within Flow.
And that was based in Calgary, right?
Calgary and Houston. Okay. So reported in Houston, but lived in Calgary. And, it was a global position. Reported in Houston, specific to the ultrasonic meter. And that was up until 2018. Then over to the east coast of Canada with the Emerson Impact partner, Atlantic Controls. And the last couple of years have been with Trillium. So, and I'd known the Trillium folks from when I first started back in 2005. They were the Daniel rep. So small family-run company, so that's the connection. So, a little entrepreneurial. It's a fun change. Emerson was great. I'm not going to take anything away from that. I'd certainly not going to hear tee off on you.
Oh yeah. Especially not on our podcast. The next podcast after, that's also how you really feel, right, Dave?
No. Emerson was a great experience. So totally enjoyed my time.
So I didn't realize you were at Emerson till 2017? 2018. Oh, wow. Why did I think you were at Spartan for a little bit?
There was a little hiatus. I was at _Norpac Controls.
Oh, okay. You're
out in Vancouver, yeah.
Okay, that's right.
And I cut something off there, but yeah.
And then, okay, that makes sense. Wow. I didn't realize you were at, and so the whole time it was looking after the Rosemount Ultrasonic, or Rosemount now. At the time, it was Daniel.
Yeah, the Daniel Ultrasonic, yeah.
Okay,
yeah.
Liquidating gas?
Correct, yeah, that was the better portion of it. So, yeah, okay. Obviously the gas is the bigger part of that portfolio. And the reality in that world, all they do is this, at the time, you just talk about diagnostics. So what would be the smart meter verification now. So
Yes.
just kind of really get in the weeds and that stuff.
Okay.
So, I mean, there is a segue to what, we're talking about just even in general with that, right? So,
Well, it makes sense that, that was your experience. And then now you find yourself at Trillium, right? It's like it's a nice natural segue with what you were doing and where you had a lot of experience is still a really important part of what you're doing right now, but you're looking at the full scope of things now.
yeah, absolutely. Yeah, it's right across the board with different technologies.
That's good. And so, but you were in sales or tech support before at Daniel?
Yeah, both.
Both.
So part of the sales and marketing group. Yeah. So and when you're in the product group, it's more of a specialist role. An SME, I guess.
Yeah.
Yeah.
Okay.
So.
And then now you found yourself at Trillium. I think I asked you this before. You don't have a job title there, right? You're kind of just a master of all, or
yeah. Well, jack of all trades. It's the master of nothing, right? So,
yeah. Well, we know you're at least a master on 𝗬𝗧𝗔𝗠𝗦 ultrasonic.
Yeah, I could still fall back on that, I guess, if I had to.
That's awesome. So you've been there for the past couple of years.
Yeah, it's just over 2 years.
Wow, time flies.
Yeah.
So maybe you could give me a little bit of rundown. Let's dive into talking about custody transfer because this subject, could get very complex. There's obviously a lot of regulatory hurdles and things to consider with that. And I want to just try to break it down as simple as possible because I'm sure there's people right now who are listening who are experts, and we'll get to the, a later point where they're going to get some value. But right now I want to make sure that people who have no idea and they just hear this and their eyes gloss over and they go, I don't know where to begin. I want to make sure that they're on board with this. So can you just talk a little bit about that? What does it even mean, right? And let's maybe go from there.
Yeah, at the basic level, it's the transfer of ownership. So, I mean, if you're moving one product from one customer to another, I mean, that's, changing hands in ownership, that's custody transfer. Now, whether or not the regulatory agencies get involved, that's, it's not just because there is a change in ownership.
Yeah.
There's, Measurement Canada, for instance, has a jurisdiction that is what we call in the downstream sector, refined products only. So,
yes.
And even then, they're not involved in everything. So, generally the idea is on the liquid side, if there is no processing left to do, it's considered a refined product. And then they may or may not be in the business of regulating it.
Interesting.
But I mean, Measurement Canada is there to write, a fair trade for all. Now, I mean, they're not, for instance, as far as I'm aware, involved in like the sale of water, but they are in things like cranberry juice. So it's not just oil. Or whether or not it's oil, but I mean, it wouldn't be just on the refined side, like diesels, kerosenes, distillates, that. So,
or when you go to the grocery store and you buy your cold cuts, right? And you go to it's all Measurement Canada, which is different than it's maybe it's related.
Yeah, for sure. Yeah. No. Yep. That's measuring cold cuts is definitely out of.
Yeah. That might not be your expert. I mean, eating cold cuts, you and I were experts on that. But so I mean, that seems like a pretty loose definition, which maybe is the intent. Because I know this might not be your expertise, but if you get into something like, on the food and beverage side, like sugar, right? Sugar could be the end, right, or liquefied sugar or something. But then if you're going to go use it in something else, how do they go about deciding what they want to? Is that all very clear, or is it more on a case-by-case basis when you work with Measurement Canada?
Yeah, I mean, and I can only speak for acetone. That's outside of where they get involved, where they don't. I know sugar, for one, actually they do get involved. So,
yes.
And it's a mass measurement, and they do it by scale. So, I mean, you could use a Coriolis meter and then validate the meter by scale, but that's how they do it. So,
gotcha.
But yeah, no, certainly that would be an example when, they're loading trucks with sugar. They do actually, it is something that Measurement Canada regulates.
Okay. So basically, yeah, how I understood custody transfer is basically how I've described it. It's, when you're selling that finished good, it's exchanging hands. Why is that so difficult? Because, why is that different and unique than just any other measurement or transfer internal to a plant?
Well, I mean, generally there's an accuracy threshold you're trying to meet, right? So,
yeah.
the seller wants to ensure that he's getting everything he can for the product, and the buyer wants to make sure that he's getting a fair deal.
Exactly.
So, you want fidelity, whatever that contractual terms is. So, I mean, Measurement Canada is there in place to ensure that there is fidelity in that transfer.
Gotcha. So custody transfer is the act of quite literally transferring that ownership of the product, and then Measurement Canada is a specific agency that gets involved to regulate the custody transfer.
Correct. Yeah, there's an act, so, yep.
Okay. So if we were looking at, I mean, your expertise and what you're focused on is a lot of the oil and gas industry, let's say, and I mean, that's where we quite often see a lot of the custody transfer applications. Maybe you could break down an example of that and walk through the different aspects of it. Like what's included in one of those solutions, right? Like why is this more than just a flow meter?
Yeah, for sure. I mean, I guess, we could just take a typical truck rack. I mean, so like a terminal loading diesel or gasoline.
Yep.
So it's considered part of the downstream sector. So right off the bat, Measurement Canada is going to be it's within Measurement Canada's jurisdiction at that point. Now, how do you know that you are compliant with Measurement Canada? What it's going to take? Again, it's not just a flow meter; it's an entire system. So, that's going to entail the meter, the upstream piping. There's going to be an air eliminator or strainer, depending on the type of meter technology. There's a register, a printer. And then the meter has to be certified, inspected and certified. So Measurement Canada has certifications for meters and ancillary devices that have to be used. So so anything you use actually has to be registered with Measurement Canada. So the meter itself would actually have already gone through a certification process.
Yes.
And is registered, your pressure transmitter is registered. And within that, the certification or the registration of the device, it'll be prescriptive on how it's used or installed.
Okay.
So, for instance, a Coriolis meter can only operate within a certain density range. Coriolis meter doesn't need upstream straight pipe. If it's a turbine meter, must have a certain amount of upstream piping. Temperature has to be taken within a certain distance. Here's your operating flow range you're allowed to operate within. That's all part of that certification process. So,
gotcha.
And those documents are all publicly available. But when you're going to be using a meter for custody transfer, you have to ensure that, again, the meter and the ancillary instrumentation is all registered.
Yeah. And so that's where, on our side at Lakeside, we're always so fixated on, we want to make sure all of our meters have the right specs that, we have the CSA approvals, we have the CRNs, and we have to have the Measurement Canada approval. But just because you buy a Coriolis from us that has Measurement Canada approval does not mean you suddenly have a Measurement Canada approved custody transfer point in your site, right?
No, correct.
It's way more, and I think that's where some of the confusion comes, because they think, I've checked that box, we're great, we can just move on. But it's much more than that. Yeah,
it's the entire system, the installation and how it's operated, and then like I said, lastly, it's a verification and an inspection.
So if I'm a customer listening, maybe this is a dumb question, but how do I know that I need this, right? Like if let's say I just we have I don't know, we're a customer in Sarnia and we transfer regularly between our site and another site. Now suddenly we have a new product that we're sending over to that site. Do I just automatically assume like what do I have to go through to validate whether this applies? Do I reach out to Measurement Canada? Do I talk to Trillium?
Yeah, I mean, it could be one or both. I mean, we've definitely seen instances where, a seller is unaware that Measurement Canada actually has some jurisdiction. But largely, there's an understanding that, when somebody's selling a product, it seems to be at least, my experience, they understand that there's some regulatory compliance requirements, and they'll reach out and try to find out what that is.
Okay.
So... and certainly, I think that's just in the petroleum industry. That's kind of carried down. Yeah, it's more when you get into things like selling sugar. What do I do here? Or alcohol. It's And alcohol is a weird one, where they're looking at excise taxes, and it's, you're still following some aspects of Measurement Canada, but it's a bit more nuanced. So, that's where really the gray area comes in.
Okay.
So, and then the other thing is, okay, if I'm selling just from one party to another, does Measurement Canada have jurisdiction? And generally the answer is, I guess technically they could by the act, but normally it's more than one customer.
Oh, so it's not just from one plant to another plant. It's plant to
multiple,
or the public.
Yeah, exactly.
Oh, okay. Because you would think
it's not it's not there to regulate every transaction.
Interesting.
Yeah. So it's to protect the downstream public ultimately. So
because you can just work out a deal amongst one party to another party.
It's contractual. Which would be indicative of what goes on south of the border.
Gotcha. Oh, okay. So that's how they do it in the U.S., or you're saying when we transferred?
No, that's how they would typically do it in the U.S.
Oh, wow.
On a contractual basis. Yeah.
Okay. Well, and it's usually just a single party to single party?
Could be, but
you could have everything.
Yeah.
Wow. So in those cases where somebody doesn't know that they have to abide by these regulatory regulations, rather, is there an auditing process involved by Measurement Canada? They're just going to site, or how do they find out about this and become aware that they're now not in compliance with something?
It'd be an auditing process.
Okay.
That's exactly what it is, yeah. So, we're going out and, as an approved service provider, you're going out and actually ensuring that the installation meets all the requirements of the Act. So, starting with, is the meter registered? Is it installed as per, the approval itself?
Okay.
Let's say a temperature and pressure transmitter, so using temperature and pressure transmitters with the proper approvals. You don't need pressure wouldn't apply to diesel or gasoline, but it does to propane. So pressure correction, there's a requirement for pressure correction.
Yeah.
But on the temperature side, do you have an approved device, and are you taking the temperature where you need to? Measurement Canada says within 1 meter of the flow point is where you're taking the temperature. So we'll go and check for things like that. Do you have a strainer and air eliminator? If it's turbine meter or PD meter, an air eliminator and strainer is required. If Coriolis meter doesn't need a strainer, but they do need an air eliminator. So custody transfer still requires single phase fluid measurement, right? So
is that where you predominantly get in? Is you have this. They have this custody transfer point. They have it installed. They need someone to come validate that they've done it right, or do you come in at periodic points to help confirm and validate that?
So there's an initial inspection, and then there's subsequent. So,
gotcha.
And then it's every 2 years after, and that would be done. If we're talking about liquids, it's done with an in situ validation, such as a prover.
Okay,
it could be a scale if it's mass or what have you. Could be totes, but in our case, we use small volume provers. So and that's a verification done every 2 years. That's a requirement by Measurement Canada.
Okay, and so maybe talk a little bit about that, because for those who are not familiar with provers, I know that you guys have quite a few provers, I believe, right?
Yeah, 12 provers.
Yeah, okay, yeah. So a few.
Yeah.
And what do these do, and why are they important in this process?
Yeah, so it's calibrated volume, and what we're doing is putting the prover in series with the meter, and we're going to displace a known volume and compare it to the meter and come up with a correction factor.
Okay. So
is what we're doing. So and Measurement Canada has a requirement, out of the box, requirements for, say, linearity, 0.3% out of the box. So we'll validate that the meter is linear, apply a meter factor correction as necessary. There's always some correction.
Okay.
And then you're ensuring that, the next time you go approve it, it stays within 0.25%. It follows out, the proving itself follows, an API practice is what it's based on. So,
okay.
Very similar. But that's ultimately what we're doing, is coming up with a meter factor and validating the proper operation of the meter.
Yeah, so you're bringing something to site, and it has to, become wetted. It has to put that volume through. And I think someone described it to me as like a big syringe almost, right? You have a fixed volume.
Actually, that's a really good, because that's what it is. It's a cylinder with a piston, and you're displacing on a fluid with that piston. Yeah.
Yeah, because that was then the next question is well, what validates that prover? But like, is that a process too?
Oh, for sure. Yeah. You do what's called a water draw. So you have a calibrated can, and you basically use that syringe to push the water into a can. So
a calibrated
can.
That's the official
measurement can. It's it's a 𝗧𝗜𝗠 can. Like I guess a company would be called 𝗧𝗜𝗠 is one of the manufacturers. Okay. But it's a can, calibrated can.
Wow, that's kind of cool.
Yeah, stainless steel, and you apply a correction for temperature, the expansion coefficient to the material itself, and then you're even applying like a viscosity correction for the fluid holdup on the walls of the can.
Wow.
So
that's pretty cool. Okay, so and then does the prover get involved when you have the initial?
Correct.
Okay, so
so it's an inspection to ensure that you've met all the requirements within the registration of the device and how it's being used, and then the final inspection is or the final certification is proving.
Okay. Wow. And then, so that's where you guys stay pretty busy then with, I'm sure, the initial inspections as well as the subsequent ones. Now, but you also get involved with designing these systems ahead of time too, right? That's not the first time you're typically involved with some of these systems.
Yeah, correct.
Okay.
Yeah. No, design just to make sure that we're following all the Measurement Canada requirements or, any of the other regulatory requirements that might be in place. So.
Yeah, because, just in talking to you, you're rhyming off things that, I don't know for sure. I know about the Coriolis. I won't debate how much I know versus Dave. I know you have quite the knowledge too, but Lakeside at whole is the expert on that, but you seem to be the expert when it comes to all things required to Measurement Canada. Like, how does someone know these things, or do they lean on someone like a Trillium to help support? Because it seems like very complicated, right, for all the different things that you need, and then the different requirements depending on what is in that solution.
Yeah, well, there's actually a training plan with Measurement Canada, to get certified.
Yes.
So,
for the customer.
Sorry, this would be for Trillium.
Gotcha.
So if you wanted to be an approved meter verifier,
I believe it. That makes sense.
There's a bureaucracy to sort through. So some of the stuff isn't always easy to find within. Online. It's all publicly available, but you to kind of parse through and try to figure out what's relevant or not.
Yeah. So, well, I bet ChatGPT might help a little bit with that now.
Yeah, fair enough.
Unless it gives you some fake information and makes stuff up and says, meg meters are fine, or I don't know.
ChatGPT is going out, isn't it? Isn't Gemini's the new one?
Oh, is it?
That's Google's. So.
Well, you know what? By the time the podcast goes live, there'll be 17 more, and I'm sure, we'll be like the old dinosaurs talking about ChatGPT still.
Yeah, fair enough. Yeah.
Okay, so I think I'm getting a bit of a grasp of this. The next question that I have, it seems like there could be multiple solutions for the same custody transfer. Like how you could use a Coriolis, you could use a turbine, you could use who gets involved with that to determine that? Is that and how does that?
That'd be the user, the seller, the buyer. They would determine. There's a threshold accuracy that a customer might be interested in, or
yes.
Again, if you're selling cranberry juice versus gasoline, different value of the product. There's a minimum threshold for Measurement Canada, but you got there's economic realities too.
Gotcha. Okay, so it's really no different than buying just a normal flow meter, right? The same criteria is that you'd have for buying a normal flow meter, so long as it can meet the Measurement Canada approval. That's really just the asterisk there, right? Yeah, no, for sure. Yeah, and you guys have a portfolio of meters. That it's pick the right meter for the purpose, right? So. Okay, that makes sense.
And you're taking into account, am I measuring in mass, or am I selling in mass, trading in mass, am I trading in volume? It's, what's the capital cost? And again, there's those economic drivers are going to determine, technology selection. Could be, things as what's in place now, whatever, what's the user comfortable with? Just in terms of maintenance support, operator understanding. So these types of things. So
that's a good point. Yeah, because you don't want to put a technology that operators are so unfamiliar with, like this is the only application at that site that has this technology. I mean, maybe it's required sometimes, but is there not? I remember hearing about Measurement Canada requiring locking out the devices and like physical lockouts. Is that's
still the case? Yeah.
Okay, that's a requirement.
Yeah, still the case. Yeah, we'll actually go and seal meters.
Yes.
So, yeah.
So now that is to prevent someone from changing.
From tampering, yeah. So,
tampering.
Yeah, you don't want to be able to go on and, change any physical parameters.
Yes.
Could be physical, or if there's an electronic register, you don't want to be changing any of the metrological inputs to the register, right? So
does that apply to every part of the system, or is that just the flow meter?
No,
everything.
Well, the metrological aspects. So so the register itself. We talk about by register, it's not a flow computer, but it has that functionality built into it. Measurement Canada would call it a register, and it's a preset. Familiar with the @load or Micromotion's got a batch controller, not preset controller, not to the preset functionality. So and by preset, that's where you can preset a volume and batch load a truck or what have you by an operator goes and says, I want 5,000 liters of product A, press start. I mean, and so that's what we consider a register. So that has to be sealed as well.
Okay. And so, but then going back to the point about operators being unfamiliar with the device. So why does that matter if they're not really supposed to touch this device?
Well, it's just from a maintenance standpoint. I mean, at some point in time, something breaks, right? There is regular maintenance on things, right? You're still doing verifications or could, I guess, preventative maintenance.
Yeah, I'm trying to think of like an example here, but so if there is an issue with the device and you can repair it, because you can't always repair it with flow meters, but let's say you can repair it, can an operator take it out of service, repair it, put it back, and then do you have to come in and now revalidate?
Yeah, it would have to be revalidated. Okay. Yeah, like let's take a turbine meter for an example,
yeah.
Right? So you start seeing a drifting meter factor, good indication that you got a bearing wearing. It's drifting over time. You've exceeded kind of the meter factor, changed the threshold.
Yes.
And so you rebuild it, and again, this turbine meter might be selected because operators know how to look for failing turbine meters. They're familiar with what the failure mode looks like, how to repair it. They got spare parts, there's a history behind it.
Okay. So,
that type of thing. But yeah, once it's rebuilt, it has to be proved again or revalidated. So it'll be sealed again.
That makes sense. Yeah. You know what obviously my experience with Micromotion is showing, because you're not used to rebuilding Micromotion, right? I mean, there's not really anything to rebuild there, right? Maybe I'm thinking you replace a display, but that's those things can kind of wait, until the next service interval, probably, right?
Yeah.
So, you mentioned something which I think would be interesting to get into is selling on mass versus selling on volume. I assume Measurement Canada dictates that, but how do you make that choice?
No, I mean, not necessarily.
Oh, okay.
No. Yeah, I mean, it could be just from if you take certain products, for instance, it might be hard to measure in volume, asphalt.
Oh.
Right? So, and some of it just comes down to you can't validate the meter with a volume metric standard, like a prover.
Yes.
Like, how do you measure, or how are you going to validate asphalt? I don't know if a volumetric standard is going to do it, right?
Good point.
So, even totes or that type of thing, like, it would be hard to determine what that volume is.
That's a good point. So
that's where you go to mass. So it goes to a scale. So,
okay.
See, Coriolis meter is a typical technology for asphalt. It is a Measurement Canada regulated product transfer. If it's and so the truck's loaded and it goes over to scale. It's a Measurement Canada approved scale.
Okay, that makes sense. Yeah, I mean, you used to, again, coming from the Coriolis world, right? You want everything to be in mass. It kind of just seems that's where you should go. Why would you even bother with volume? Now you got to deal with pressure and temperature corrections, but I guess it comes down to proving, right?
Yeah, exactly. The reference standard itself.
Now you could probably measure. I mean, you can definitely measure everything with a Measurement Canada scale. but I guess it just comes down to, is it cost effective to do that? Right. I got to imagine a scale like of a substantial size to prove could be pretty expensive.
You can imagine if you're, So, I mean, especially if you consider like on the pipeline, for instance, if you're doing, thousands of liters an hour, or per minute even, doing by mass. Yeah. There's a practical aspect to it. So, and then again, this kind of, it's outside of my expertise, but I mean, I think there's also just basically, a legacy of how things have been done.
Yeah.
That's often, like, hey, we've always sold in volume. We're going to sell in volume. And that's how the regulations are designed and set up. Like, I'm just kind of spitballing. Like, but, certainly seen time and time again. And, in the, if you talk, coming from the gas space, but just, you get into the AGA standards and the API standards. There's a lot of it's because we've done it that way. So
is there? I mean, you kind of got me thinking now about the proving on a volume basis. So, if you have a massive custody transfer point, right? You're transferring thousands or millions of liters, let's say. Is there any requirements for how big of a prover? Like, you can't just put in 10 liters and say it's proved, right? Like how do you determine that?
Well, yeah, I mean, there are API regulations for minimum sizes for provers and how much volume has to be captured and, what have you. So, I mean, ultimately it comes down to the prover is sized for the flow rate. Yeah. Right. So the reference standard. So we don't need a minimum flow like on a small volume prover. But if we're talking about, properly sizing a prover, there's guidelines to what the minimum volume is. So and generally it's how many pulses have to be captured from the meter to ensure that you're getting a representative flow rate that, is going to be repeatable, reproducible, and can be corrected. So,
because you're not taking the heart output from many of these devices, you're looking at the frequency output.
Yeah, it's frequency output.
Gotcha. And that's because it's going to be more accurate than pulling from like heart or field bus or something like that.
Yeah, no. Well, time latency would be a big part of it, right? So, so you can immediately, the update rate to count pulses versus, a digital protocol. Yeah, there's certainly, you can achieve that with a smaller volume.
Gotcha.
By comparison. So, I mean, the pulse is a legacy thing as well too, right? You're talking about, mechanical output meters. So turbine meters or PB meters.
Oh, good point. They're spinning.
So,
you get those pulses naturally.
Yeah, I mean, that's where, the industry adopted that. And then you're also talking about, processing capability within your prover and its interface, right? So, technology goes back decades or wherever it spans. Yeah. You don't have super fast microprocessors. So, but I mean, that's ultimately where the pulse started, and that's been adopted with, ultrasonic meters or coilless meters, where you're still using a pulse. It's still got a pulse output, just not mechanically derived anymore. Yeah,
that's interesting though. I didn't. That's cool. So the provers are going to give you based on the volume basis. So do you ever run into where you have too small of a prover, like for the size that you guys you have your 12 provers? Does that cover you for most of the applications you see, or you have to say no to some?
Well, they typically come into where you have manufactured pulse meters, like coilless meters or ultrasonic meters.
Gotcha.
So where the electronics is outputting a pulse from the measured volume, but it's not being directly outputted.
Yeah.
So you have that, you have time latency gaps, right? So if you have a too small a volume, the prover's already measured that volume, the meter's trying to catch up, right?
Yeah.
So it's processing and then outputting a pulse.
Yeah.
So you have that time latency or those delays. So, and that was a common thing with coilless meters. That's, coilless meter, you'd have to sometimes prove special mode.
Gotcha.
So you have a rapid
Fire of the pulses.
Well, it's rapid it's actually the processing of what the flow, the determined flow is, and then what the output of pulse is.
Wow.
Yeah. So,
but for the applications that you typically work on, you have like Trillium has the sufficient provers for that, or like,
yeah. Well, we'll make sure that the provers size sufficiently.
Okay.
Yeah.
I'm just curious if there's like some massive applications out there that like you're like, no, we have to say no. These are way too big of.
I mean, well, there's certainly be instances of, large ultrasonic meters. Like you don't have a 24-inch ultrasonic meter, and I'm gonna have a small volume prover for it.
Good point. And that's where I think like we have brought, like I think you can bring the entire spool of that to get Measurement Canada approved at a third-party facility. I know we've done that. We've certainly done that with some of our customers on gas.
I was going to say, yeah, we're not doing that on liquid.
Yeah. Sorry.
Because there actually isn't. Yeah. So actually, liquid ultrasonic meters actually aren't even Measurement Canada approved, or maybe they're getting there. I don't know where that actually is, but they're actually not approved.
Yeah.
So
I had to think about that for a second.
Yeah. Kind of catching me here, but.
That's funny. You got me into the weeds of like, I just kind of, it's interesting. I guess I know maybe a little more, or maybe I know enough to be dangerous. So I kind of am trying to fill in the gaps that I think.
Gas a little different where,
natural gas, that is, not just.
Natural gas, where you're taking and calibrating the artifact at a lab versus, with liquids, it's going to be in situ.
Gotcha.
So, I mean, there are liquid calibration labs out there.
Yes.
In the US and in Europe, but in Canada, we don't take a lab calibrated device and put it in the field. So, and that's primarily due just to the responses with viscosity and Reynolds number changes. So that are going to change the meter factor with different environmental conditions.
Yeah, gotcha. Okay, so I mean, you have a lot of experience when it comes to custody transfer. I don't know if you had to generalize, like, what are the biggest problems that you see, or the biggest issues that these systems end up having that you have to help with?
Well, I mean, if they weren't aware of what the design requirements were on the front end. So, and that tends to be more, same way it could be food and bev, but we've all seen it, in the petroleum industry where someone wasn't aware that there was a Measurement Canada jurisdiction. Or they found it out of the fact, and then, hey, just like you mentioned before, hey, I've got a Measurement Canada approved meter. We're good to go. So it's more than just the meter; it's the entire system and how it's operated. So I would say, that'd be the bigger component of it. I mean, large users, they've established design standards and practices.
Yes.
They know this.
Gotcha.
So,
okay.
As well as we would.
So would you say for the most part, for those types of users, it's a well-oiled machine for them, or are there still hiccups that you have to come and work with them on?
Well, I think it's well-oiled machine because the design is well-oiled, not that the knowledge is necessarily there.
Oh, that's a fair point.
It's you're taking a known kind of standard in installation and going from there, not really reinventing the wheel. So
to that point, have you noticed any changes in industry related to custody transfer, or has it been, status quo because it works and tried and true?
If you're talking where Measurement Canada gets involved, I mean, there's a cost, right, to bring a new technology in and get approved, and also just changing industry standards. A very conservative, risk-adverse industry.
Yeah.
And often the incentives are stacked, if there's changes, it's because a manufacturer wants to roll out a new technology, or
interesting.
It's driven, like the incentives aren't always seen as beneficial to the customer, let's say.
Gotcha.
So it could be, but
so a lot of times those changes will be driven from a manufacturer saying, hey, we have this new technology that we think could meet these requirements, could be used here. We want to now get it approved.
Yeah, and I mean, there's going to be entrenched interests all around, right? I mean, that's generally, where there is regulations, there's regulatory capture. So People make money regulating.
Yeah.
You know, there's moats and barriers to entry.
Yeah.
People like, so
Yeah, that's fair.
right. Ultimately, you know, if there's a technology that there and there's a big enough business case, I think it can get, you know, driven through. But again, it's a conservative industry, and I think there's always some risk aversion, especially when you're talking about custody transfer.
Yeah.
You know, it's not going to be probably when you know, and it's not necessarily going to be on the forefront of technological change. So, you know, you'll see more of that in where there's the barrier to entries are lower process measurements,
that's fair.
right? As opposed to custody transfer, there's kind of going to be more at stake.
Yeah.
So, yeah.
So I mean, I guess it's the risk reward, right? Like,
Yeah, no,
what really is the benefit to making any changes? If like, and maybe there are some, but the risk of screwing this up is probably way too high. That it's status quo is probably because it works, right? So
it works, yeah. I mean, and I guess you know, if you think about, you know, maybe some things that could change or, you know, using onboard diagnostics, you know, the smart meter verification or the heartbeat, another trademark term, but where the meter can self-validate that it's still accurate. I mean, that'd be the holy grail.
Yeah.
So you see more of that in the gas space than you do in the liquid space. I mean, those types of practices are employed with ultrasonic meters now, right? Where, you know, Measurement Canada allows, you know, an indefinite interval to some, maybe I'm not using that term correctly, but it's certainly a lengthened calibration interval by using onboard diagnostics to validate the meter.
Yeah.
Right. So, I mean, that's there in the gas space, so that precedent's established. It's not the same in when we're talking about liquid products, and that's because there tends to be, you know, the seasonal changes or environmental changes with respect to Reynolds number and viscosity that are going to change a meter factor a lot more than you see in a gas meter. So natural gas doesn't really, you know, you don't really have any of those changes that are going to affect the meter output.
Oh, I hadn't thought about it like that. That makes sense. It's kind of funny as you're talking. It reminds me of you know, in the pharma industry, right, or life sciences, where you know, they either, depending on the customer, depending on the site, they have requirements to calibrate all their flow meters, right?
Sure.
And so smart meter verification, which, you know, we've talked about on this podcast before, which is a tool to validate whether or not the Coriolis is in the same condition as when it left the factory. And if it is, then therefore the calibration should still be fine. So we've been able to use that with some of those customers to say, hey, look, you don't need to pull out every single Coriolis from your site every single year, 6 months, 2 months, whatever it is,
Sure.
and get it calibrated, because 10 out of 10 times they're not changing anything.
No.
So it's a huge cost. But obviously, I mean, you know, it's high risk. You don't want to screw up a batch, which could be millions and millions or maybe even more, right?
Sure.
So we've been able to work with some customers to demonstrate SMV and just the power of being able to go from, you know, maybe calibrating every 3 months to calibrating every 6 months or a year. I mean, there's substantial savings. So, I mean, obviously there's regulatory issues here which prevent that from just you being able to do that, but you can see it in other areas of your plant for sure.
Yeah, I mean, actually, like the minimum requirement I mentioned, kind of 2 years. I mean, there's a lot of terminals that would calibrate a lot more often than that, right? Monthly.
Really, eh?
Yeah. So, I mean, where they see the risk, so where they see the changes.
Yeah.
So,
I guess you look at the cost of how much it is to versus what you're transferring, and you go, you know what? Let's just recalibrate it and not have to worry.
Yeah, they see them. Yeah, I mean, they have enough data to see what the meter factor shifts might be. You know, there's within a certain control range. API, some of the latest chapters now talk about, you know, control ranges for meter factors just with seasonality. But yeah, I mean, there's you know, I guess there's some historical precedent. They would have some precedent and understanding what their meter factors look like over time.
Wow, that's kind of cool. So they are you saying like they can just set it, or they would still
Well, no, they understand what the risk exposure is.
Oh, I see.
Right, is kind of where I'm going with that. I
Gotcha.
mean, yeah. Oh, sorry.
They wouldn't just say, "Hey, we're using AI. This is what the meter factor should be."
Well, I think that's where they want to go.
Interesting.
Right. So, I mean, there's certainly, I can tell you right now, there are companies investing in studies in that right now. You know,
that's kind of cool.
They would like to move away. I mean, proving is a huge cost, right?
Yeah.
So, especially doing a monthly or what have you. You know, if you had enough if you had a big enough data set, do you understand what the seasonal changes look like on this meter? That addresses the product changes. Now, do I also know what different failure modes look like? How do I know when I might have a certain failure mode? So these are type of the inputs they're looking at. I mean, to what, level of certainty they get to. It's certainly not to the point where it's custody transfer at this point. I don't know.
Yeah.
And I don't, where some of those, I mean, again, there's some companies, there's companies out west looking at that now with their conclusions they're drawing.
That's pretty cool. So yeah, it'd be like, we know this meter, we know this application, we know the seasonality impacts, we know how this is going to drift or not drift, right?
Yep.
And we also know the cost to either prove this meter or to remove it and, calibrate it or validate it at a third-party facility. And we go, you know what? This is probably what it is. And if we're off by this much, which we think is the risk, it actually is a lower cost to us just to keep it and absorb that hit in inaccuracy than to go do that thing. Huh.
I mean, that would be if there's an internal transfer. I don't know if
Yes.
your buyer might not say that.
Yeah.
Right.
Yeah.
So,
yeah.
I mean, but if you're talking about incorporating something like that into, where there's a regulatory jurisdiction, those are the things you'd have to substantiate, right? With, sufficient data.
Yes.
Right. And then beyond that, you'd probably still have to have, a buyer, take on that type of practice or,
yeah.
So
I think I'm more thinking about internal, non-custody transfer points.
Yeah.
Internal
allocation, internal accounting for sure.
That's where I could see the or at least you start there and then you build up enough data and enough confidence before you can make a point at a custody transfer point and go through the hurdles there. But
sure. Yeah. I mean, that's where things eventually will go. I'd have to believe. So,
yeah. Well, I mean, that's kind of where I was going to go to next. Like, where do you think some? I mean, obviously, this is regulatory compliance is status quo, but there's got to be some other changes driven, not just from the manufacturers.
You probably see it first at the at the provincial level. So we're talking about royalty reporting, so fiscal measurement, where there's a high level of accuracy required. We don't necessarily call it custody transfer, but the government wants to know. Take it the Newfoundland government, the Alberta government, what's coming under the ground, or out from under the ocean, and they want to ensure that they're maximizing what royalty they get. I mean, there is a progressive is the word, but they tend to adopt more of those industry leading practices to do that. You'll see it there before you would see it, in within the federal bureaucracy, I think so.
Gotcha. Okay. So when we're talking Measurement Canada, that's going to be at the federal level. So you're saying there's another provincial level beyond that gets?
Yeah. Well, would this be for royalties, right?
Gotcha.
So yeah. So for reporting royalties, that would be, or just even environmental protection regulations. So leak detection, that type of thing. I mean.
Oh, I see.
Pipeline integrity.
Gotcha.
The province gets involved in that. So
at that
there's
level. So you start there.
Yeah, and then environmental reporting, just in terms of they do look at the balance across a gas plant. What's being flared, what's coming in, what's going out, what's going in, what's coming out for produced water.
Gotcha.
That type of thing.
Yeah, so it's not a custody transfer point, but it's something that requires high level of accuracy, and
there's accuracy requirements, right?
The government requires you to report some of these things.
And there's certain calibration or verification requirements for all those points.
Gotcha.
So that's where you'll see, those barriers fall first. So where you're relying on the internal capabilities in meter. So see, you already smart meter verification, or I'm trying to remember how the Alberta Directive 17. What the actual term is, but I mean that'd be one of the primary jurisdictions where they allow smart meters to you can use onboard diagnostics to verify the meter without kind of any ancillary calibration, whether it be lab or otherwise.
Yeah. Wow. I mean, that is pretty cool. Definitely a time and cost. And honestly, a bit of a risk saver too, right? I mean, having to pull a meter from service definitely has some risks. If someone could, we've definitely seen it with Coriolis, damage or
fair enough. Ultrasonics for sure. I guess if you're sending whole, meter spools.
Yeah.
So
yeah, I'm just thinking of enough. Well, typically it's more like the tri-clamp installations of Coriolis, or someone just over tightens the heck out of it, and you're like, "Oh, your tubes are bent. We'll sell you a new one." So
yeah, fair enough. Okay, yeah.
What about for Trillium? What is Trillium focused on in the next few years, or kind of continue to serve customers in the same capacity, or?
Yeah, I mean, our niche is really in that kind of that legacy business. So that's really where we've captured our niche. So, I think, our management has set up, we want to be, from pickup trucks. We fit between pickup trucks and boardrooms. So,
I like that.
Kind of, so we cover that. We're not going to be in the C-suite, but, we kind of fill that middle gap. So, we know, again, what the what the traditional methods are, and we understand the regulatory requirements and different jurisdictions. So that's our niche. That's kind of where we'll focus our time now. Who knows? I mean, we have a huge data set in terms of just proven records. Who knows what we could do?
Yeah.
Right. So
totally.
We get a lot of metadata there, right? So.
Well, it's definitely always interesting every time we talk. I feel like, you're not, it's like, where the heck are you now? What are you doing now? You're doing this with what? Like, all right, that sounds pretty cool. It keeps it interesting, right?
Yeah, I think, we're reacting to, our customer requirements and demands. But a lot of that's still, supporting the legacy type practices and installations, and not always mentioned Canada for talking about, overseas. It's following, still custody transfer, but we're following API practices.
Gotcha.
So American Petroleum Institute, the custody transfer guy standards that are used globally.
Yep. Oh wow.
But that's on a contractual level, right? So as opposed to, necessarily a government jurisdiction. In some cases it is, but yeah.
Gotcha. Cool. Okay. Well, Dave, thank you very much for your time. I definitely learned a lot. Hopefully listeners did too. If they have any questions, if they want to learn more about custody transfer, Measurement Canada requirements, where can they go? Who can they reach out to?
Yeah. Trillium Measurement Control. You can, Google that, or
add you on LinkedIn, or no, forget about that.
No, well, yeah, there's probably better people to add than me.
Okay.
So, but
that's fine.
Yeah, reach out. Any further questions we can help with, certainly. Yeah. Love the opportunity.
Awesome.
No,
Great.
good deal.
Cool.
Good chatting.
Yeah, thanks for your time, Dave.
All right.
Really appreciate it.
All right.
Till next time.